Khan Academy website. It says that there are 170,589,700 lessons delivered, which is a lot of hits on this website. Now you should know, I know from my own blog that these numbers are often inflated because anytime someone comes to the page it counts as a hit, but when you look at the numbers in more detail, a large percent of people that come to a website only stay on it for a few seconds. So I don't know whether this 170 million is counting people who went through an entire lesson, or if that's just the number of people who just went to the website at all. Even if 99% of the people leave after a few seconds, still it's a lot of hits. So what I thought I would do here is take from the perspective of a student and see how I would go about navigating the website to locate an answer to how to do a homework problem. Now, I've done some videos critiquing Khan already, and those have been about lessons that I thought weren't so good. As I've looked through more and more videos, most of the lessons are decent. Most of the math lessons don't have giant errors in them. There's issues about whether math is more of a creative endeavor, encouraging kids to think about things, not just proofs, but really being more imaginative with math and what sort of the goal of math is. But assuming the goal is to learn some proofs and also to learn some algorithms, most of these videos are okay. Now, I'm thinking of a topic here. Here's a famous math question. It's called adding rational expressions. You get these two expressions. This topic is a popular topic with math teachers. You got to know how to factor. You have to know how to find least common multiple, things like that. So it's a popular topic. And imagine my teacher taught me that, or that's what was taught at school that day, and I was absent or whatever, and I decide I'm going to go to Khan Academy to learn how to do this question. See how that would work. I would go to watch, I'd go to math, I'd go to algebra, I'd hit it, and I would see this bunch of videos and topics with these playlists on them. Now, I'm a math teacher, so I am able to find this much easier, but if someone's not, they'd look at this and they may not even be sure, what is it? Is it linear equations? What is it? Well, it would most likely be under polynomials. So I click there, and I look through the videos, and I find there is something with the word rational expressions in it. Let's see. Here you go. There's no adding rational expressions, but there's subtracting rational expressions, which is similar. So that's where our best bet is. I noticed just as a math teacher that factoring is over here, assuming these are meant to be done sort of chronologically, and I'm nervous about that because the question that I showed you over here would require factoring. But let's just see what this subtracting rational expressions is all about. Click on it, and here's the video. Sometimes you can tell how many times something's been watched, in general, by how many comments there are. And there's very few comments if this video's been watched, thousands of times or not. Let's take a look at what this is about.
And just like the case when you are subtracting fractions, you have to make sure, or adding fractions for that, you have to make sure that you have a common denominator. And over here, it looks like we have kind of the same components, but they're not quite the same thing. So we need to find the least common multiple.
So looking at this example, it doesn't look a lot like my example. This one doesn't have factoring in it. And as a kid, I don't know what I would do. I guess I would sort of click over here to see, he's still doing this example where there's nothing to factor. Maybe I click over there, click over here. I'm getting a sinking feeling. that this entire video
simplify that
is about this one question, which is not going to be useful for the question I was trying to do for my homework. So what would a kid do at this point? Well, they might go to some other website, but let's just say that they are intent on using Khan Academy. Well, nothing else here seems to fit it, but then I saw this CK12org Algebra 1 examples, and when I click there, I did find down here adding rational expressions example 1, and let's take a look. This example looks a little bit...
Let's do a few examples adding rational expressions. So let's say we had negative x squared over x squared minus 7x plus 6.
So that requires factoring.
To that, I want to add plus x minus 4. So to some degree, what I want to do in this first example,
this isn't exactly what I'm looking for. Maybe example 2. Example 2 is what I was looking for.
Let's add some more rational, 2 times 2.
And as you can see, it's similar.
1/6.
And his explanation here is pretty good also.
2 times 3.
I approve of this, using numerical example as a sort of analogy to this harder example. Well, I found it, and that's good, but I doubt that most kids would have been able to do the detective work. They may not even know that this topic is called rational expressions. Maybe they could have something where you type in a question and it tells you what video you want, whatever it is, but as it is right now, there are very few kids that would have been able to locate this video. Now, some kids might be taking Khan Academy as a course of like self-teaching themselves, and they do the videos in chronological order and do them all. But I think most kids who come to a website just want to see how to do that question, and it would take me a good 5-6 minutes to locate this video. I don't know that a kid would be able to do that. A huge amount of time is spent in geometry on what's called triangle proofs. Here's a typical one. Sorry for the messiness of this one. This isn't a professionally made video for instruction purposes, but more for critiquing the structure of the Khan Academy lessons and how they're sort of laid out and what logical order they're in. So I hope you forgive me for that. I guess there could be a next generation of videos critiquing and making fun of videos, and we could have a sort of meta thing going on. But for now, we have to prove, in order to prove triangle ACD is congruent to angle BCD, we're going to need to first prove these two triangles congruent, and then use corresponding parts of congruent triangles are congruent. This is a huge topic in geometry. I'm going to say that it's weeks of learning the different postulates and doing more and more complicated examples, and then eventually moving on to overlapping triangles. And it's to me it's quintessential geometry. So let's imagine I wanted to do that question. What would I do? Okay, I go to watch, go down here to math, go to geometry, that's my course I'm taking. And I see here basic geometry. Seems like pretty basic geometry, but this is all about areas and perimeters, which is actually most geometry courses do at the very end. Euclidean geometry, some basic ideas about parallel lines, things like that. Angles. Looks like if they're doing sum of angles is 180, it means they've done parallel lines already. Finally, we get to triangles. So it seems like this is a huge topic, proving triangles congruent. And what I see here is that there's only 2 official examples: congruent triangle proof example and congruent triangle example 2. So I hope that the first one's really easy to build us up to it, and the second one's a little hard. But you need like a good 10-15 examples of congruent triangles. But if we look at his first example,
So we have these two parallel lines, line segment A, B, and line segment CD. They are parallel, I should say they're parallel line segments. And then we have these transversals that go across them. So you have this transversal BC right over here, and you have this transversal AD. And what this diagram tells us...
So this isn't, I don't like this so much for first example of triangle congruences because it uses parallel lines and alternate interior angles, it seems, and often in courses they this topic comes up later. Like first you learn how to prove triangles congruent, simpler examples that use midpoints and things like that, and then later on they learn parallel lines, and then they start doing triangle proofs with parallel lines. So I don't know if this is the best first example.
This is that the distance between A and E, this little hash mark, says that this line segment is the same distance as the distance between E and D. Or another way to think about it is that point E of line segment AD. And what I want to think about in this video is point E also the midpoint of line segment BC? So this is the question right over here. So is E the midpoint of line segment BC?
And this is a pretty challenging question actually, because proving E is the midpoints of BC is going to require first proving the triangle is congruent. For a first example, I would just stop at, are these two triangles, are they congruent? That would be like a four-step proof. Then the next thing would be to prove that BE is congruent to EC. That would add an extra step to the proof using corresponding parts of corresponding triangles are congruent. And then one more step would be to say that E is the midpoints of BC. So this is a lot of steps for the first example of congruent triangles. So this isn't going to help so much the kid who's coming, it's the first day of proofs, and they're just trying to do this question. There's too much going on here. I see mine actually goes one extra step beyond the triangle proof, but not to the point of saying, let's say CD is an angle bisector of ACB. So let's see what his second example is. And these are the only two examples. This is, again, a tremendous topic, triangles, congruent triangles, and strategies for proving triangles congruent. Okay, here it is. And I know just by looking at this screenshot from the video that this is an overlapping triangle question, very very complicated. Hold on, why is that popping up? Okay. So I know just from looking at this still shot that this is extremely complicated question that's got the overlapping triangles, very difficult. And if those are your two examples, remember that the kid who's coming to Khan Academy is not someone who is the strongest student. So if they didn't already understand it in class, I do not see that these two videos are going to clear it up for that kid. Some of the comments here: best teacher, Sal, nice Sal. Please help. I don't care if. It's kind of hard. I'm just looking at what people say. Not much. Not many comments on this actually. I would go out on a limb to say that very few students in this country and world learned how to prove triangles congruent and how to use corresponding parts of congruent triangles are congruent to prove to do questions like this from Khan Academy. So they have a lot of work to do with adding a lot of examples, building up from easy ones to harder ones, and things like that. Just going to look to see if there's any maybe these worked examples. Let's take a look. Okay, so I see here CA, deductive reasoning, more proofs. So I think that this might be what I'm looking for.
All right, we're on problem number 7.
That's not
Is it the
related
same
to
as their logic of vertical angles are congruent? Next, so I want to give a counterexample. So let me make one.
These are not.
Oh, whoops.
These are not proofs. This isn't helpful.
To make your
So, in summary, it would be very difficult for a student, the type of student who is on the internet looking for help with their homework, to learn how to prove triangles congruent and what to do after that from these videos. Doesn't mean that Khan is not capable of building up with smaller examples and having, 20, 30 examples of different difficulty levels, but right now he has just 2. And well, that's what I think. The structure and the organization needs a lot of work, even when the videos aren't too bad. Like those videos I just saw were actually okay, but even with the videos being okay, there's another major issue with the structure. Okay, that's good for now.